Question number 34. A satellite in a circular orbit around the Earth needs to be reduce its orbital radius. Okay. So what's happening? So you have, I not put on the timer. Just a minute. Okay. Put on the timer. Right. So it needs to reduce its orbital radius. It means what? So this is the Earth. This is the Earth, and a satellite is now in this orbit, and it needs to reduce its orbit. It means it's a second orbit here. It needs to come from here to here, here to here. It has to come like this. Okay. Now what is the next question? It says what is the work done by the satellite rocket engine and the engine change in kinetic energy resulting from this shift in orbital height? Okay. So first thing is that let us look at the what is the energy, total work energy. So total energy, let us say this is R1, this is R2 here. Now we know total energy is equal to minus potential energy divided by 2. In other words, this becomes minus of what is potential energy here? Potential energy here would be minus GMM, this is M, this is M here, MM divided by R1 minus of minus GMM by R2. So this is what you get. So now this is negative here. So this is minus delta potential energy by 2. So as a result of this, you get this as GMM divided by 1 by R2 minus 1 by R1. 1 by R2 minus 1 by R1. Okay, so therefore this will be the potential energy. This is a negative here. This is negative here. So there will be this will be the potential energy over here. Since R1 is greater than R2, R1 is greater than R2, right? R1 is greater than R2. 1 by R1 will be less than 1 by R2. In other words, 1 by R2 will be greater than 1 by R1. Okay, which means the quantity inside this bracket is greater than 0. But here you see this becomes negative. Thus the total energy is still negative only. Okay, you can look at it in the other way around also. As we come nearby to the Earth, the particle is getting more and more bound. So therefore work done by the satellite rocket engine is always negative when you are coming towards it. So thus you can say this is negative. Okay, so therefore this positive and positive goes away. So one of these options should be correct. Then kinetic energy. Now what is kinetic energy? Kinetic energy is nothing but half mv square, where m is the mass of the satellite and v is the r by 2 speed, v is v0 0, and we know v0 is given by the formula root of gm divided by r, where r is the radius. So when it is at this point, what will happen here? Kinetic energy will become half m into gm divided by r. Which r is this? This is r2. Now you note here r1 was greater than r2, 1 by R1 is less than 1 by R2, or 1 by R2 greater than 1 by R2. Which means this 1 by R2, this kinetic energy that you get here is larger than this kinetic energy whenever the particle is nearby to the surface of the Earth. Okay, at a lower altitude, definitely kinetic energy is farther, is higher. Okay, in other words, the satellite should now move faster and faster over here. Okay, so which means kinetic energy has increased as compared to this position. So the answer is negative here and increase here. Answer is C. Okay.